Okay, number 8 now. We have a trinomial again. I don't see a coefficient here, so we can use CAT certified, but I'm going to rewrite this another way just so it looks a little bit easier maybe. If I write this t squared minus 2t squared plus 1, that looks a lot like x squared minus 2x plus 1, right? We could factor that with the CAT certified method very easily. It's x minus 1, x minus 1. So you can think of it that way, and then since instead of x we have t squared, we would just end up with t squared minus 1, t squared minus 1. And then since these are what? Differences of two perfect squares, both of them, we're going to have t plus 1, t minus 1 here. Then we're going to factor this one and we get t plus 1, t minus 1 there. This is our final factored form for number 8. Let's look at another way to do it. You can just think of it this is the second way to do number 8. You can look back on the video a couple seconds to find the first way to do it. But again, you're just taking the square root of this and the square root of this. This is a perfect square trinomial. So you can think of just taking t squared here, and then we could take a 1 there and just look at that sign. So it's t squared minus 1 squared. T squared minus 1 is a difference of two perfect squares, so you'll have to factor that. So if we expand this, remember anything squared is itself repeated. So this is a difference of two perfect squares twice, t squared minus 1, or I'm sorry, t plus 1, t minus 1, and then this one, t plus 1, t minus 1. You might find another way to do this. It's just think of this as t squared squared. So when you are working on factoring it, it just becomes t squared in the front and t squared here. Number 9 here, I'm going to show you two different ways to do it. What if we thought about this one as a squared plus 9a plus 18. I'll rewrite that just without the parentheses as a squared plus 9a plus 18. This looks like CAT certified because no coefficient here and no GCFs. So what multiply to positive 18 and add to 9 looks like positive 6 and positive 3. So I'm going to rewrite this as a plus 6, a plus 3. Now I'm going to substitute these x minus 2's in for our a's, just because I simplified it by making x minus 2. You can think of a equaling x minus 2. So we'll just plug it back in here. So we get x minus 2 plus 6, and then we got x minus 2 plus 3. We'll simplify this and we get x plus 4, and we get x plus 1. I'll show you another way to do it. If we have x minus 2 quantity squared plus 9 times the quantity of x minus 2 plus 18, this is the second way to do number 9. I can FOIL this stuff out, this piece, to get x minus 2, x minus 2. Then I'm going to distribute this so I get 9x minus 18 plus 18. I'm going to FOIL these out to get x squared minus 4x plus 4 plus 9x, and then these cancel out. Negative 18 plus 18 like terms. So now I'm going to combine like terms here. So I get x squared plus 5x plus 4. That looks like a CAT certified because no GCF and no coefficient here. So positive 4. They need to multiply to positive 4 and add to positive 5. Looks like positive 4 and positive 1. So we get x plus 4, x plus 1, which is the same answer we got the other way. The other way would be considered more elegant. This will work now that you know how to factor, but this way you got to be careful if you have really big numbers. You may end up trying a bunch of different stuff. that could get really ugly. So I recommend the other way, but this will work too for number 9.